Hi everyone, my name is Neoh Ke Ying. Today I'm going to talk about my project that I have did in neural network class. My title is Comparative Analysis of Machine Learning Models for Early Liver Disease Detections. My domain is talk about liver disease. And why I want to talk about this? Because we have 5,125 people dead because of liver disease in Malaysia, according to WHO. And the solution is, if the diagnosis can be diagnosed in early stage, then the liver disease can obviously improve patients' probability recovery. So I consider to use machine learning models as a tools for patients and doctors to detect liver disease early. I had separate this video into three sections. Section 1 is about the dataset I use. Section 2 is about the MLP coding in Python that I have did. And section 3 is about findings and conclusions. Section 1. I had taken my dataset from UCI, which named ILPD Indian liver patient dataset, which included 583 instances and 10 features. For the features, which included patient's age, gender, and information of their blood. This is a target which name selected. I had did some preprocess in my data, which I changed the gender from string into numeric, which is female into 0, male into 1. And the selector, the patients which detected, I changed it into 1, and the healthy individual, I changed it into 0. Section 2. Now let me explain about my MLP coding in Python. First, I try to import the library to make sure my coding can work. In the first line, I'm going to load about the data set from my computer by CSV file. Because of my data is an imbalanced data set, so I have the oversampling of my data set. So I consider to use smart widget in Python to resample my minor class. So here I use smart random state 42, and here I try to apply the oversample for the minor class. In this liver disease detection, I had used 5-fold cross-validation in the 100 hidden layer size. Why I choose 100 hidden layer size? Because I have 10 features, so I choose to use 100. If I use 50 or 20 hidden layer size, it will be underfitting. If I use more than 100 hidden layer size, it will be overfitting. So 100 is the most suitable for the model performance. It can make the model performance well. From here, I try to convert the resample data into arrays and then generate the training and testing data into each fold. It will become 5-fold. And here I use to train the data and predict the disease. And I use these metrics to evaluate the models: accuracy, F1 score, precision, recall, and MSE. Let us discuss about the output of the MLP. So first, we can see that the dataset preview and features and 5 instances. Here we can see that the original class distributions, the people who detected disease is 416, and the healthy individual is 167. So I use the smart widget, resample again the dataset to make them balance. So I get 416 per target. From this classification report, we can see that the result of precision, recall, F1 score of the class 0 and class 1. So I'm going to explain about each metric. What are they going to use about? Precision is used to measure the correctness of predicted positive cases, while recall indicates how many actual positive cases are detected by the model. And F1 score is talk about the model is more effective in identifying which target. The last one is accuracy. It is talk about the correctly classifies the instances in test data. So from this classification report, we can see that MLP model is more accuracy in predicting class 1. So from this overall result, we can see that the test accuracy gets 70%, means that this model have 70% of the correctness in classify the instances in test data. And F1 score, it get 0.74, means that it get balance between precision and recall for classifying liver disease. In precision, it get 0.729, means that it has 70% of prediction cases are correct. And the recall, it get 0.752 as correct, identifying 75% of actual liver disease cases. Lastly, we can see that the MSE, we get 0.29. You can see that it aligns with the accuracy, and the lower MSE means that it has lower prediction errors. This is my final output that I have run in Streamlit. This is my final. The end user can be input in this field. Let's try. The end 20 mil. Let's say I'm 22, I'm female, and then total volume is 0.24. Direct volume is 0.2. Okay, and line 300. 0.1. Oops, it shows that value must be greater than or equal to 10. Then could be 12. Total protein is 5.6. Albumin is 6.5. Oops, value must be less than or equal to 5.5. So 4.5. Wait, sure, 3.4. Okay, then click predict. So it shows that the liver disease is detected. I'm a liver disease patient. Yeah, just kidding. And this is my visualized graph. We can see that the accuracy and the MSE. Because I use 5-fold cross-validation, so it has 5 different points. It shows that the first fold is the worst because we have lower accuracy and higher MSE. And it shows that the fourth fold is a better fold because it's at the higher accuracy and lowest MSE. Section 3. Since we only implement MLP in Python, so to compare all the machine learning models, I decided to use Orange tools as the comparative tools. So from this table, it shows all performance of the machine learning models. We can see that random forest is the highest accuracy depending to the other machine learning models. So means that random forest is the best models for predicting liver disease, while the SVM has a low accuracy. So SVM is not a good choice. Well, I did a graph slide for a better visualize. So we can see that the red line always stand in the highest performance, which is random forest. And the second highest performance is the purple line, which is 3. And the worst performance is SVM, which is yellow line. So we can see that neural network is stand in the neutral line. So it is not the best model for detect the liver disease. In my own perceptions, random forest and decision tree is better to use to classify numerical data. While neural network model is better to use in image patterns recognitions, classifications. That's all from me. Thank you.